In this video we'll be doing some incline plane problems. So I've done a couple of these on the channel before, but I'm just going to do some revision on some of this stuff. I might have done some of these questions in the previous video, but some of them are new, so feel free. I'm going to be doing a better in-depth on incline planes. So an incline plane is basically where you have a slope with some angle, and you have some object, let's say it's a ball, and you release it and it just falls down the slope, okay? So how do we work out like the acceleration pretty much down the slope, and how fast it takes and how long it will take pretty much? So if you have a block that's going down a slope, right? There's one main force that's acting on it that's causing it to fall down the slope, and that's gravity. So you have a force of gravity that's pulling it down. Okay, you have force of gravity. And the way we work out how long it takes to fall down the slope is that we can break this whole thing up into vector components. Okay, and using a bit of geometry proof, this angle here is equal to this angle in here. Okay. And so, oh, whoopsie daisy, rubbed the whole triangle out. Okay, and this is a right angle, and this is a right angle, okay? The force of gravity is the hypotenuse of this little force triangle. Now, the force this way is going to be the force of gravity multiplied by the sine of the angle, okay? The force here is going to be the force of gravity multiplied by the cos of the angle, okay? Now, the better representation of these forces is this force goes directly up. So this is otherwise known as the normal force. It's equivalent to this here. And this force here is the force going down the slope. This is otherwise known as, I'd just like to call it F subscript X. Okay. So this is basically our diagram. Now, if we have a force of friction, the friction force is going to act the opposite way up here. Okay. So this is basically our diagram of everything that's happening in an incline plane. Alright? And of course, the main formula you'll be using for these questions is F equals ma. Okay? Force is mass times acceleration. Okay? Alright, so let's get straight into a problem to reinforce our understanding of an incline plane. Alright? So have a go at this first one. A 400 Newton object is accelerating down a 25-degree incline. The coefficient of friction is 0.19. What is the force of friction, the normal force, the mass, and the net force and the acceleration? So just up here, I forgot to say the force of friction is the friction coefficient multiplied by the normal force. If you're in the QCAA syllabus, you don't need to know this, okay? But if you're not, then and you want to reinforce your understanding of an inclined plane, know that the friction force is the coefficient of friction multiplied by the normal force. Alright, so have a go at this question and then I'll start solving it. So let's just draw, because we're going to need to draw it at some point, our incline. Okay, so we have 25 degrees here, and we have an object, and let's just start drawing what's actually happening. So this is drawing our vectors. So straight at the back, this is the force of gravity, okay? Now we got told it's a 400 Newton object. That's a force because it's got the units Newton. So our Fg, our force of gravity, is 400 Newtons. Now notice this question is asking for a lot. It's asking for the force of friction, the normal force, the mass, the net force, and the acceleration. Now straight off the back, we can work out the mass of this object, because the force of gravity is equal to the mass of the object multiplied by g, which is 9.8. So 400 is equal to the mass multiplied by 9.8, which is divided by 9.8, and you should get the mass. So putting that into our calculator, get 400 divided by 9.8. It's approximately 40.82 kilograms. Okay, this is SI units. So I'm just going to move all this over here now. Make that a bit smaller. Alright, so we found the mass already, so that's ticked off. Let's find the force, this force here. So that force there is going to be the force in the x direction, so it's going to be F subscript x is going to be the force of gravity multiplied by the cosine, not the cosine, the sine of the angle. This angle in here is 25 degrees. Okay, so f of x, f subscript x is going to be 400 sine of 25 degrees. Okay, now we gotta put that into our calculator because we don't know what a sine of 25 degrees is. Sine of 25 degrees. Alright, so we get 169.05 newtons. Okay, cool. Let's move that over here, make that a bit smaller. Alright, cool. Now we gotta work out this force, because the reason we need this force here is because we need to work out the normal force, and the normal force is equal to this force here. Okay? So by definition, the normal force is a force that is perpendicular to the surface the object is sitting on. So this force here is going to be the normal force. It's going to be equal to the force of gravity multiplied by the cos of the angle. Okay? So Fn is equal to 400 cos of 25 degrees. So Fn, putting that into our calculator, we're going to have 362.5 newtons approximately. Alright, let's move that to the side so it's not in our way. So what have we worked out? We've worked out the normal force, so we've answered another bit of the question. We got to work out a frictional force. So there's a force of friction because it's got a coefficient of friction 9 the surface of this incline. So we have a force of friction acting this way. Alright? Now the force of friction is the friction coefficient multiplied by the normal force. Now friction coefficient is 0.19. So we have our normal force, so all we got to do to find our force of friction is multiply this number by this force here. Okay? So we're going to have F subscript F equal to 0.19 multiplied by 362.5. Okay? So F subscript N, subscript F is going to be multiplied by 362.5. So we're going to have a frictional force of 68.875 newtons. Actually, let's just round that, so it's going to be 88. Make that a bit smaller. It's not in our way. Oh, what the heck? I think I just brought that down. Hold up. Let's keep that up there. Sorry. Alright. So I've worked out the frictional force, the normal force, and the mass. The net force. Now, what is the net force? Now, when they say net force, they're talking about the force down the incline. So notice in our diagram here, we have a force going this way and a force going this way. Okay? So the net force is the net force basically down the incline. So the way we write it is we like to write it as sigma F subscript net is going to be equal to let's say down the incline is positive orientation, so this number is positive, minus the force that's going the opposite direction, which is the force of friction, so F subscript F. Okay, so this is our equation for our net force down the incline. So working that out, it's just going to be our force down the incline, which is 169.05 minus the force of friction, which is 68.88, and then putting that into our calculator, we can work out the net force down the incline, 68.88, and we get 100.17 newtons. Okay. Now the reason we needed the net force is because the acceleration of this block down this incline is going to be the net force divided by the mass, because F equals ma, so therefore A equals F over m, right? Therefore, if you want the net acceleration, you're going to need the net force, okay? So our net acceleration down the incline is going to be the net force divided by the mass. So it's going to be 100.17 divided by 40.82. Putting that into our calculator. So 100.17 divided by 40.82. And you should get an acceleration of 2.45 meters per second. Okay? Boom. And we have found everything this question is asking of us. If you have any questions, leave some in the comments and I'll try my best to answer them. Alright, let's move on to our next question of the video. Alright, a box is sliding down a slope that meets the ground at a 35-degree angle. Find the rate at which the box accelerates down the slope. Its mass is 200 grams. Alright, so if you are feeling confident with this topic, feel free to have a go at this question without me. If you're not, just wait and I'll start solving it in a sec. Alright, straight at the back, let's draw our incline. That's a terrible line. Alright. So we have a box that slides down, and we got to find how it accelerates. Now notice we've been given the mass, but it's in grams. So way to convert to kilograms from grams is to divide by 1,000. So our actual mass in kilos is going to be 200 divided by 1,000, which is equal to 0.2 kg. Okay? Because all of our stuff needs to be in SI units. Okay? Standard units across the world. Alright? Now, incline. We haven't been given a coefficient of friction, so we can assume that this surface is pretty smooth, so there's minimal friction acting on it. Okay. Let's just make this a bit bigger so I can draw on it. So F of gravity goes straight down. So when you're drawing this triangle here, always have the force of gravity going straight down. It's the hypotenuse of this little force triangle here. Okay, so this is FG, this is FN, and this is FX. Okay, G, oh, that's sine theta, and this is FG cos theta. Now in this question we don't need to work out the normal force because we don't have any friction. So all we care about is this force component here in this question. Okay, and I like to draw our little force diagram a bit better. So I like to have this one going this way and this force going up. Okay, so this is Fx. This is Fn. Alright. Our angle is 35 degrees. So 35 degrees here, 35 degrees here. So F of x is going to be, we need to work out our force of gravity. So Fg is going to be our mass multiplied by 9.8. So putting that into our calculator, 0.2 multiplied by 9.8, get approximately 1.96 newtons. Okay, so making that a bit smaller so I can move that out the way. Up there. So Fg is going to be 1 point. Hold up. Sorry, my computer's lagging a bit. Alright, so 1.96 sine of 35. Okay, put that into your calculator and they'll give you the force down the slope, sine of 35, and we get 1.12 newtons. Okay. Now, since there's no friction going down, down the slope, the net force is just going to be equal to the force down. Okay, because there's no friction going against it. So therefore, our net acceleration is just going to be the force we calculated down the slope. So f of x, f subscript f, divided by the mass. So it's going to be 1.12 divided by 0.2. So putting that into a calculator, it's going to be 5.6 meters per second. And that's the answer to this question. Alright, cool. If you have any questions, leave some in the comments. Let's go down to our last question. Alright, a block of mass 10 is released from rest on a rough slope incline to the horizontal at an angle of 30 degrees. The coefficient of friction is 0.5. Find the acceleration of the block. Alright, let's draw a little scenario once again. So draw your incline. You have a block. It has a force of gravity acting straight down, and it's got these force vector components. Okay, this is FG. This angle is 30 degrees because the incline is 30 degrees. This is Fx, which is Fg sine of the angle. This is our normal force, which is Fg cos of the angle. Draw little vector diagrams. So this is Fx, this is Fn. Now we've been told it's a rough surface, so we have a force of friction as well. So I'm going to use a different color for that. So we have F subscript F. Alright, that's our diagram. It's pretty detailed. We've also been told our friction coefficient is 0.5, and we know the force of friction is the friction coefficient multiplied by the normal force. So we're going to need to find the normal force as well as the force down the slope. Alright, so first we've got to find our force of gravity. So F subscript G is going to be mass times gravity. So Fg is going to be 10 times by 9.8. Okay, putting that into your calculator, that's 98 newtons. Alright, so therefore our force down the slope is going to be 98 sine of 30 degrees. Therefore F subscript X is going to be, putting that to a calculator, sine 30 degrees, 49 newtons, sorry. Our normal force is going to be 98 cos of 30 degrees. So putting that into a calculator, we're going to have cos of 30 degrees, which is going to be 49 root 3, which is approximately 84.87 newtons. Okay. Our force of friction is going to be the friction coefficient, which is 0.5, multiplied by the normal force, which is 84.87. So our force of friction is going to be 0.5 multiplied by that. So we're going to have 42.43 newtons. Okay. So therefore, our net force down the incline is going to be the force down the slope minus the force of friction. So that's going to be equal to 49 minus 42.43. Now, if the force of friction is greater than the force down the slope, then the object's just going to stay still. But as we can see, this object is just making it down the slope. Okay? Alright, therefore our net acceleration is the net force divided by the mass. So our net acceleration is going to be 6.57 divided by our mass, which is 10. So our acceleration down the slope is 0.657 meters per second, okay? And that is the answer to that question. Alright, I hope you enjoyed the video. If you learnt something, please leave a thumbs up and subscribe. I'll be doing another video more on this stuff. Alright, thank you.